Hey, it's Tony from Adafruit, and in this video I'm going to look at how to load files and run code with MicroPython. So this is actually a really important video because I want to show a workflow for how to put your code onto a MicroPython board and make it run just like an Arduino board. So if you're familiar with Arduino, you write code in the Arduino IDE and then you upload that to a board like an Arduino Uno, and that code will run forever on that board. So there's a setup function and a loop function that you fill in with your code, and then that's going to run. And what we've looked at so far with MicroPython is basically connecting to a MicroPython board, typing in some code manually, having it run that code, which is great for like interactively controlling hardware. You know, you can turn an LED on and off. But you might start to wonder, okay, how do I make this little MicroPython board like an Arduino where I can have code that always runs as soon as the board powers up? And I'll show you it's actually possible. There's some really cool stuff with MicroPython, specifically the file system that MicroPython has. So there's a little file system built into each of the boards, and you can add files like Python source code, or you can put configuration or maybe art or assets or any kind of a file in there. You can have directories. And then there are certain files like Python source code that get run whenever the board turns on or whenever it boots up or resets. And that's really powerful because you can put your code inside of that file and have it run, and then you can have that code referencing other files if you want. You know, you can get really advanced. But that's what we're going to look at. So I want to show how to make this workflow where you don't have to type in your code at the REPL or the read, evaluate, print loop all the time. That you can put your code into a file and then have that board or have that file run whenever the board resets. So we'll just kind of dive in and look at that. And by the way, if you're totally new to MicroPython, if you haven't seen anything or heard anything yet about it, look in the video description below when this goes up on YouTube. I'll have a link to the very first guide I've done in a series of basically what is MicroPython. So check that out first, give you a little bit of an overview. And then there are a few other guides that I've done since then that I'll link to from that guide that kind of show you how to load MicroPython, how to blink an LED, and then that'll get you up to this point where you're learning how to actually put files and run code on the board. So let's dive in and see what we've got here. We'll go to the main shot. And this is basically a view of a guide that was just published. And this guide is all about how to load files and run code. Surprise, surprise, what I'm talking about here. And so in this video, I'm just going to kind of walk through the guide. We'll see some of the process. And I really just want to get across the point that here's how you can make a workflow that's similar to Arduino. So maybe to start there, you might notice in the corner, this is not a MicroPython board that I have right here. This is an Arduino Uno. And I just wanted to show, you know, if maybe you're familiar, maybe you're not familiar with Arduino, this is kind of how Arduino works today, where you have a sketch like this. So you're in a really nice little editor here, the Arduino IDE. You can type in your code. There are two main parts to every Arduino sketch. There's the setup function right here, which you put in code that runs once, like as soon as the board boots up. If there's something you need to do once, like configure the pins as inputs or outputs, you put it into the setup function here. And then there's a loop function which will get called over and over. So in this sketch, this is just the simple blink and LED sketch. This basically just turns on the LED, delays for a second, turns off the LED, and then delays for a second. Exactly like the code I did in the last video for MicroPython, you know, same kind of functionality. But Arduino makes it nice in that they give you this loop function, so you put your code into that loop function, and then it will automatically be called just over and over as fast as possible on the Arduino board. So let's just upload this to my Arduino. So I have an Arduino Uno right here. It's all set up to program it. You know, real straightforward, simple stuff if you ever used Arduino. But I wanted to show that this is kind of what you can do with MicroPython these days. And it's maybe not as slick and fancy as Arduino yet. There's no nice little IDE, but you can use your own text editor. I'll show you in some simple tools to push your code onto a MicroPython board and run it almost like the Arduino is running it here. Now I just uploaded this. And if you notice right here, there's a little LED that's blinking. So that's actually this pin 13 on here. So this code is running now on this board. And this is the cool thing about the Arduino. I can unplug it, and then if I plug it back in, it remembers the code that was written to it. So notice that LED starts blinking again. And so that's pretty powerful. Like I wrote this sketch, I pushed it out to the Arduino board, it remembers that code, and so as soon as I power it up, it starts running it. So you can imagine if this is a really advanced sketch, maybe it's like listening to sensors and lighting LEDs, or maybe playing sound effects and things. It's going to remember that, and then you just apply power and it'll keep doing that forever. Now what we've seen with MicroPython so far is that it doesn't really work like that. So sorry Arduino Uno, we'll move you out of the way here, and let's get the star of the show right here. This is the ESP8266, the Feather Huzzah ESP8266. I've used this in all the MicroPython videos so far, and it's a real nice little board. It's a Wi-Fi microcontroller. I'll have a link in the description below. You can go check it out and see more details about it, but it runs MicroPython beautifully. And I have a little LED wired to it. This is the exact same board from the previous video on how to light an LED with MicroPython. And I'll put a link to this guide in the description below. So here's the guide that I followed in the last video. So real simple and straightforward. Now in this video, or in this guide, I went through, okay, here's the code that you need to run to blink this LED. And I guess just to show that it still works, let's do it. So I have my board connected right here, and I'll use the screen tool. So we'll go to the Scilab's USB to UART chip, which is just the serial converter on this board. Go to the guide. It talks a little bit more about how you can find out what the serial port is for your MicroPython board. I'm going to connect an 115200 baud. So I'm in the Python REPL right now, the read, evaluate, print loop. And in here, I can just start running Python code. So I'll import the machine library, create the LED class, and then make a pin object. Pin 15 is what I have. I think it's 15. Let me check. Yeah, it's 15. Yeah. Yes, it is 15. Yeah, okay, just double checking. It's always a little unsure sometimes. Pin 15 is what I have the LED hooked up to. I want to make it an output, so there's a special syntax for this. Again, this is all just recap from the last video. And then I can just say LED.high, and it turns on the LED, and LED.low turns it off. So that's pretty cool. And then like I showed in the previous video, you can run a little loop that just blinks your LED over and over. You can add a delay function to it. I show that right inside of here, so you can see, LED.high, time.sleep for half a second, LED.low, time.sleep for half a second. Notice this is exactly like the Arduino code. Like, that's pretty cool. It's maybe even a little bit simpler. Like, it's kind of nice that you can just say, I want to set this to a high or a low value. So, same kind of code, same kind of idea here. But the problem is I have to be in this REPL typing this code in for this to run. How do I get that functionality with Arduino where I power up the board and it just starts blinking the LED? And maybe even more importantly too, how do I make it so that I don't have to type my code into this editor here, into this REPL? It's nice, but it's not as nice as having like copy and paste and nice editing tools like that. So let's solve this problem. I will show you what we can do. So I just exited out a screen. And if you go to this guide, the basics of how to load and run files, take a look at it. And I talk about there are different tools you can use to access the file system on a MicroPython board. It's a really powerful thing that MicroPython has, where, as far as I understand, I think every MicroPython board has a file system. I don't know if that's going to be true for every board in the future. I mean, it really depends on how much flash memory they have. But most boards have a file system, and I believe it's a proper FAT file system, which is just like a standard kind of file system. I might be totally wrong on that, but it feels like a normal file system in the sense that you can have directories, and you can have subdirectories inside of there, and you can have files inside of there. So you can have a whole hierarchy of things. And the really cool thing is that you access all of those files just using the standard Python functions. So I mentioned in here that you can use the Python open function to open a file, or the read or the write function to read and write data in a file. So just the normal way that you would expect. Again, MicroPython doesn't try to have a lot of surprises. It tries to be as similar to Python 3 as it can. So that's really cool. And we'll see that there's some powerful things you can do when you put files onto a board. Like, there's certain special files that when you put code inside of there, they'll be run whenever the board boots up. So that's maybe how we can solve the part of the problem of how do you have code run when the board starts up. And then the other part is, how do we actually edit these files? And so because the board has a file system, there are actually some tools that people have created that let you copy files from your computer onto a MicroPython board. And so that's pretty powerful, because with that, I could go into a text editor on my computer, write some Python code, save it locally on my computer, and then run a little command to copy that file onto the MicroPython board. And I talk about here, there are actually multiple tools that let you do this. So the ESP8266, which is the board that I'm using right now, it has this web REPL that we're actually going to look at in a future video. But with the web REPL, you can upload a file. It has a little graphical interface through a web page to send files, and I think you can even download files. But that's cool. The problem is you have to be connected to the ESP8266 network. So like either it has to run a wireless access point that you connect your computer to, or it needs to be connected to your wireless network, and then you need to know like the IP address and how to access it, which can be a little annoying sometimes. I mean, it's great if you're set up for that, but if you're like developing something that's disconnecting and connecting to Wi-Fi, that could be a little annoying. So there are some other alternatives though. So there's another tool, there's one called rshell, and I haven't really used a lot of these tools, but I link to, most of these are kind of up to date and published on the MicroPython forum. So check out the forum post, you can learn about this tool there. And another one is MPF shell, similar tool. I think MPF shell supports a different set of boards like the YPi board, boards that need a telnet interface to access them. So, you know, there are these various options. There's also a fourth option, so one that I actually created called ampie, or the Adafruit MicroPython tool. And I'll put a link to the GitHub repository with it here. On ampie, it's a very similar tool to rshell and MPF shell. The reason I made a whole new tool for this is that I wanted to make something that was a little bit simpler than rshell and MPF shell, whereas these two tools are pretty advanced. Like they let you run a full shell with the MicroPython board where you can use the REPL, you can send files, you can receive files, you can do a lot of things with them. But I think, you know, for my needs, I really just need a tool to only send files, download files, run code. Like you really do nothing else. Like don't worry about trying to be a shell or an environment to send and receive input. You know, I just want to have a real simple tool to send and receive files so that, you know, hopefully it'll be easy to keep it up to date and working with lots of different MicroPython boards. Now the big thing about all these tools is that they all operate over the serial connection. So like on the Feather Huzzah, it has a little USB to serial bridge chip right here. That's connected to my computer. And so the way these tools work is they connect to the REPL, you know, like we saw right here, I'm connected to this Python REPL, and they'll actually run the code to copy your file over to the Python or the file system that MicroPython exposes. And so that kind of means that your board has to have that serial REPL set up. And if you aren't sure about all that, I actually talk about it in the guide here, how to load MicroPython on a board, and I mentioned this a few times in this guide. There's a page in here that tells you exactly how to set up the serial REPL, so you do want to make sure that you can go through and get this serial REPL set up. You might need to install some drivers and some things like that for your board, but once you get that set up, once you can connect to a board with the serial tools, then you're good to go and you can start using these tools. So that's what we're going to look at in this guide. Then I'll show you how you can use ampie to copy files onto a MicroPython board. You can even just run a file. I have a little run command where you can write a file on your computer, send it over to the board to run and see the results, just like if you were in the Arduino IDE and you wrote some code and pushed it out to the board to see what happens. And then I'll show you also that you can use ampie to save a file in a certain spot so that it's run whenever the board boots up. So we'll just kind of dive in and start going through the steps here to use this tool. So the first thing in this tutorial, you know, after you've gotten your MicroPython board and you've loaded MicroPython and you can access the serial REPL, you'll need to install the ampie tool. And I've tried to make this really easy. I've put it on the Python package index so that you just need to install Python. And I've even made it easy. It works with both Python 2 and Python 3. So you jump through a few hoops and you can write code that works with both of those. And so I talk about here, you know, make sure you have Python installed. If you're on Linux or Mac OS X, you've probably got it installed already. On Windows, you do need to run an installer from python.org. And make sure to check the box that says add Python to my system path. In the Python 2 installer, you have to add it as a feature. In the Python 3 installer, it's a checkbox. You know, that's just the way things are. So make sure to check that, because if you don't do that, whenever you try to run the Python command in a terminal, it's going to say, I don't know what the Python command is. So, go rerun the installer and make sure to check that box to fix that if you run into that problem. And you want to make sure you have a somewhat recent version of Python, like at least 2.7.9, I want to say, because that's the version of Python where they started to package the pip package manager inside of Python. So as long as you've installed Python within the last year, you should have a version that's good enough. You want to be able to run this pip command because that's going to install packages. And really all you need to do is run this pip install Adafruit ampie or pip3 install Adafruit ampie if you're using Python 3, which that's what I'm going to use here. I'm using Mac OS 10. I have Homebrew with Python 3 installed, but again, I talk about all the different various options here in the guide. Even if you're on Mac OS 10 with Homebrew with Python 2, there's this pip2 command that you want to run here. So lots of different little variations here, unfortunately, but just if you're really unsure, you probably have Python 2 and you could use this pip install command, and if this fails, try pip3. If that fails, you probably need to run as root with sudo, and if that fails, make sure you've got Python installed because you probably don't have it installed at that point. Okay, so let's just run pip3 install Adafruit-ampie, and this will install the tool, and it's pretty simple and straightforward. You'll see a little bit more output because I already have a few libraries installed, but once it's installed, then just real quickly run ampie-help, and this should print out help information like this. So this shows kind of the usage. So it just says, hey, this is the tool to control a MicroPython board over a serial connection. And the way ampie works is it has a bunch of sub-commands. So you can run a sub-command like, let's say, the ls command. And let's just see what happens. Well, okay, so this worked, and I'll explain why this worked in a second. But most commands actually have help. So if you run the command --help, then this should print out help information. Now, you might actually need to specify a serial port because all of the subcommands require a serial port be specified so that it knows how to talk to the board. And unfortunately, as just a side effect, even just to run the help command, you have to have a serial port specified. So in my case, I'm going to use that Scilab serial port. And so then I can say, okay, the ls command, and we'll run help here and see, and it shows the help. Now you might notice, like, I was able to run that ls command and help without adding that port option. And that's because you can actually set an environment variable. So I've done this ahead of time. If I echo the ampie_port environment variable, you can see I set this to my Scilab's USB to UART board, which is the one that I'm connected to here. So the way I did this on Mac OS 10, you can just use export ampie_port equals, and then whatever values like dev, tty, Scilab, USB to UART, you could set this. On Windows, I believe the syntax is set ampie port equals, and then like your COM port, like COM5 or COM4 for this. So try that. Now, one thing to realize is that this export will only stick around as long as I have this terminal window open. As soon as I close this window, it goes away. It's not remembered forever. There are different ways to make this stick forever. You can put it in like your bash profile. I won't get into it here. But this is just a convenience thing. It really just saves you from having to type this --port option all the time. So because I've set that environment variable, I can now run this ls command. Oops, I have to say ampie to run this command. So that's kind of cool. It makes it a little bit easier so that you're not constantly typing this. Now, in the tutorial, or in the guide rather, I show explicitly using this --port option, so there's no harm in using that. It's easy enough to specify that. If you're not sure how to set environment variables, don't worry about it. Just specify the port everywhere. But okay, so we've installed ampie. We see it works. So this is all good. So let's just kind of go on through the guide and see what else it mentions. Oh, and I also mentioned in the guide, and I'm not going to show in the video here, if you want, you can install from the source code on GitHub for the ampie tool. So you can clone the code and then use a standard Python setup.py install process. This is useful if for some reason you want to get the code from GitHub. I'm generally good about keeping it up to date in the Python package index. Like if I push a change to GitHub, I'll push it out to the Python package index, but maybe there's something more recent in GitHub. Or if you want to like modify the code or change it, things like that, you probably want to do a source install like this so that you can change it. And I even mention if you use the develop mode, that makes it easy so that you can change the source code and it'll update the tool automatically. So So, I won't get into it in this video here, but if you need to, here's how you install it from the source. Okay, so the next page here, this is specific to the ESP8266. So you want to make sure that debug output is disabled. And debug output is basically if I go to the web REPL on my board, so I'm just going to connect, using the screen tool like I've shown a bunch of times. When I see this REPL, I don't see anything else here. Like I can just say, okay, print hello world, for example, and I'm printing out the Python code here. You might sometimes notice, though, with the ESP8266 that random things are printed out to the screen. Like I've seen sometimes there's like a underscore, like analog input or something equals. Like there's debug output from the analog input or analog to digital converter. There's debug output if it was previously connected to a Wi-Fi network and it's trying to reconnect to that network. You'll see it's spamming a bunch of output to the debug, to the serial REPL here. And unfortunately, this causes a problem with tools like ampie because remember, they use this serial REPL to send and receive files. And the way they do that is they actually run Python code and expect to get back a very specific result. Like they'll create a file or they'll get a file. And if the board is printing debug output while that's happening, it's going to break everything. So it's not going to be able to send files. It won't even really be able to connect to the board. So that's a problem. And luckily, it's easy to fix this. And you might not even need to do anything. So I mentioned at the top here, if you're using an official release build of MicroPython, so you want to go to the micropython.org webpage, and it's not super clear, unfortunately, which ones are the official release builds. I believe that any version like this that ends in a simple version number, like version 1.8.3.bin, I believe that's an official release, versus these above. You can see these are version 1.8.3-37-GD076FAE. So I'm pretty sure that these are daily builds, like builds that happen multiple times within a day. And I think there's even like a git commit hash next to it. So from what I understand, these are development builds that have the debug output enabled by default, whereas these simpler release builds don't have debug output enabled by default. So as long as you flash one of these release builds to your MicroPython board or your ESP8266, you shouldn't have to worry about any of this debug output stuff. So that would be my recommendation. If you're not sure, grab the latest official release, something with a simple version like this, flash that to your board, and you should be okay with this. But if for some reason, if you've built your own firmware, or if you're using one of these snapshot builds, then you do want to go through and actually run some of these commands here to disable the debug output. Now I mentioned all you need to do is connect to the serial REPL and just run these commands, import ESP, and don't worry if you see debug output being printed as you're trying to type this stuff in. The MicroPython's serial REPL is smart enough to realize that it's only reading the input that you send it, not the stuff that's being printed to the screen. But you import the ESP module, and then you run esp.osdebug, this is a function, and you pass it none, which just means whenever it wants to print debug input or output, print it to the null handler or to no handler, because I think by default it tries to print it out to the output here. And after you do this, you should see that there's no more debug output printed out to the board. So, a handy little tip. If you're trying to use ampie and if it's failing to connect to the board, make sure if you're using the ESP8266 that you're using either the official release build or you've gone in and run this set of 2 commands right here to stop the debug output. Now, unfortunately, like I mentioned down here, this won't stick around. So when you reset the board, like if you unplug it or plug it back in, you're going to have to run these commands again. But I do mention, and we'll see at the end of this guide, you can actually edit a file on the MicroPython board, this boot.py file, and you can add these 2 commands to it. And you'll actually see they're in that file already, just commented out. So if you uncomment those files or those lines, you can save that file back to your board. And then when it boots up, debug output should always be disabled, so you don't need to worry about it anymore. So just a quick note, remember, keep this in mind because it will trip you up if you don't do this, and you might not even realize it. Like, things might work fine, and then something causes some debug output to occur at the wrong moment, and then you're not going to be able to upload to the board, and you'll be really confused because you're not going to get a really good error message. You know, things just are going to start failing basically for this. Okay, cool. So let's see how to run code. So this is basically, like I was showing, remember with the Arduino IDE, you have a nice little text editor. You can type your code in, and then you just press a button to upload it to the board. Now we'll get pretty close. It's not going to be press a button and run it on your MicroPython board, but I'll show you ampie has a command to run a file from your computer on a MicroPython board. So I'm going to exit out of the web repo right here, and we'll just clear my screen here. And I'll go into actually a text editor here. So I'm in this, I'm in the same directory as my terminal right here, this MicroPython files directory. So let's make a new file. We'll just call this thing test.py, and we'll say print hello world, and we'll make it more fun. We'll say for I in range of 1 to 11. This means loop through the numbers 1 through 10, because the range function, you can pass it the starting value and the ending value, but it only goes up to the ending value. It doesn't include the ending value. So if you want to loop through 10, you need to include 11 up here. But so we'll say, let's loop through numbers 1 through 10 and just print them out. So, you know, we're just going to print out the first 10 numbers. So I'll save this. And this is just standard Python. So I'm not even going to use MicroPython. You know, I can run Python 3 test.py and hello world numbers 1 through 10. So that's cool. But let's see, how do we run this on our MicroPython board? So with ampie, there is a run command. And so if I run this, and remember, you normally need to specify the port unless you've set the environment variable like I set ahead of time. So, you know, in the guide, I actually show here that, you know, here's the port option that you can use. But for this video, I'm going to skip it because it just adds, you know, unnecessary stuff. I've set that environment variable ahead of time. So I'm going to use the run command, and we're going to point it at that test.py file that's in this directory here. So let's see what happens here. Okay, so this looks pretty similar. You know, I see the same output here. Hello world 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But this is the cool thing. What ampie just did, it connected to the board, you know, using the serial port that it knew from the environment variable that I set, and it sent this test.py file right here over to the board, and it had it run that code on the board. And then it grabbed the output and printed it to the screen right here so we can see the output of our board. And just to prove that I'm not making this up, let's add something else to this code. Let's make it light up the LED. So we'll import that machine module. We'll create an LED, and so we'll say machine.pin, pin 15, and this is an output. And then let's say LED.high, so we'll have it turn on the LED. And so let's try this again. Let's run our code. We're going to use the run command. We'll use this test.py, and I run it, and hey, check that out. The LED just turned on, and we printed out all the same values here again. So we know for sure that this code is running on this chip because it's the only thing that can light up that LED. And if I want, I can go and edit this code. You know, let's make the LED off now when it starts up. So we do that, and it turns off the LED. So pretty cool. And you can maybe start to see that this is very similar to Arduino, where you can write code locally here. I've got a nice little text editor, and by the way, this is the Atom text editor. If you've never used this Atom text editor, this is what I use, open source, free, very nice little editor. Atom.io is the website. I'll put a link in the description below when this goes up on YouTube. I like Atom, but there are plenty of other text editors. You know, check out whatever you like. There's full-fledged Python IDEs like PyCharm, although realize I don't think a lot of those Python IDEs know about MicroPython. But because MicroPython is so similar to Python 3, probably doesn't matter too much. But you could use a fancy editor, you could use a simple editor, you could use, you know, maybe something like Vim or Emacs, you know, whatever you like. Use your favorite editor. You could use Notepad probably, and it would be okay. So I'm just using the Atom text editor, again, editing this file locally, and then using that run command in ampie to run this against my board. Now let me show you something interesting. So you might be thinking, okay, so let's actually blink this LED in a loop. So let's make an infinite loop while true, and let's say LED.high, and then I should probably import the time module at the top. Oops, because the time module has the delay function in here. So we'll say about time.sleep for half a second. This is exactly the same code I did in the previous video on how to blink an LED. So say time.sleep for half a second. So this loop is basically just going to turn the LED on, sleep, turn the LED off, sleep. Okay, so let's save this. Now let's use the run command and let's see kind of what happens here. So this is good. The LED is blinking, like it's running our code. But here's kind of the problem. The run command is still running because it's waiting for this loop to finish. But this loop is never going to finish because it's an infinite loop. So it's, while true, that's never stopping. So that can be kind of annoying. You can press Control-C and that's going to stop the ampie command. But I kind of thought of this and realized that this could be annoying and problematic for people. So I added an option to the run command. If you do -- no output. So notice how I'm going to run the command like this. So ampie run -- no output and then the file to run. So when I do this, oops, I misspelled it. I was staring right at it and misspelled it. There we go. No output. So notice it ran and it just came back and it's still running my code right here. It's blinking the LED. But this is the cool thing, the no output option, or I shortened it so that you can just do -n. So just do -n and this will do the same thing. This tells ampie, run the code, but don't stick around and wait for whatever main loop or whatever's happening in the code to finish. It also means that you won't see any output. So if I print, like, how about starting loop in my code right here, then I'm not going to see this when I run this command. I'll at least see the effects here. It's in that loop, it's blinking the LED, but I don't get that output for this. And so it's just something to be aware of that, you do have to think about what is your script going to do. Is it printing out output that you want to read, or is it, just running something forever like an Arduino sketch? Now, if you do want, like, let's put some output in the loop. We'll say like print, blinking maybe. So every time it does a full blink of the LED, it'll print out blinking to the console here. So let's run this, and I'm going to do the no output option. Now the cool thing is, so it's running, the LED is blinking, you can see. Let's connect to the web or the serial REPL again. So we'll go to the Scilabs device, and you can actually see it's printing out every second blinking. So every time it does a full blink of the LED, it's printing it out because it's running this code right here. So that's pretty powerful and cool. If you're writing your code and maybe you do want to see like some debug output or something like that, throw some print statements in and then just open the serial console and start looking at what's happening. Just like in the Arduino IDE, there's the serial monitor. So you write a sketch and you can do serial.println to print out debug info, and then you open the serial monitor to see. Think of the serial REPL with MicroPython just like the serial monitor from Arduino, so you can see serial output with it in addition to running code and things like that inside of it. So that's pretty cool. Okay, cool. So we've got our code blinking. Let's go back to the guide and let's see what else we can do here. So I talk about in this page exactly what we just went through. So the no output option, use that option whenever you're running a script that's going to loop forever. And then the other thing that I kind of mentioned at the bottom, and I'll maybe make a better point here too, is that, if you're looking at this code and if you're familiar with Arduino, actually let me open up Arduino again just to show you what the loop and the setup functions look like. So let's open Arduino. You might start to see that this Python code kind of sort of looks like an Arduino sketch if you squint a little bit and if you know where to put these setup and loop functions. So okay, so for example, here is the Arduino sketch that we looked at originally that just blinks an LED. So remember, in Arduino there's a setup function that's called once. So if you look at this code, everything before this loop starts is the setup. So you might imagine like setup code goes here at the top, and I can put anything inside of here. I can import modules, I can initialize my LED object, I can print out some stuff, whatever I want to do, I put it up here before I go into this loop. And then inside of this loop, this is where your loop code goes. So this is like in the Arduino sketch, the loop function down here. This is run over and over by Arduino. And so you don't really see it, but inside of Arduino, it has a loop just like this, an infinite loop that's running your code, and it's just calling the loop function in your sketch over and over. Now it's nice how Arduino kind of separates this out, so you just implement these functions, whereas in MicroPython here, you kind of do it yourself, which is kind of nice. You can see it's not that much more complex. I'm just adding this while true loop, and then inside of there, I've got to indent, all of my code because this is standard Python syntax. All the code inside of a loop has to be indented. But I can get more advanced. I don't have to do an infinite loop inside of here. If I wanted, if there's some case that causes my program to stop for some reason, I could break out of this loop if I wanted. So again, really powerful. I'm just trying to show, here's how you go from this Arduino world of running code, putting your setup code in the setup function and putting your loop code in the loop function. With MicroPython, you kind of do it yourself, and it's not as scary as you might think. Just put all of the code you want to run first at the top of your program, and then make a loop and put the code that you want to run forever in that loop down here. So that's kind of how you should think about moving Arduino-style code into MicroPython code. And if we look at it, maybe I'll put the formatting back. Let's just kind of compare the code here. I mean, this is pretty similar code. So you can see, like in the Arduino sketch, in its setup, it configures the pin as an output, which is exactly what this line does right here. We have a few extra lines up here to import some modules, but you don't really see it. In the Arduino IDE, there are all these include statements that are added, so there's some stuff that's happening behind the scenes here that's kind of similar, but think of this almost like when you're using a library or a module. In Arduino, same kind of thing in Python. You have to import libraries and modules, and so that you use that import statement here. But here's where our setup code is. So we're just initializing that pin 15 as an output. We're setting it low, which we don't do in this sketch here, but you could add that if you wanted right here. You could say digital write 13 low, just to turn it off when it starts. And then in the loop function, the Arduino sketch, we turn on the LED, delay, turn off the LED, and delay. Exactly what we do in our loop function here. So, we turn it on, delay, turn it off, delay, and then print some output here that's, just for some demonstration purposes. But that's cool. So you can see, the code is very similar. You just see the skeleton or the loop code itself inside of here, which is nice that you've got a little bit more control. Like, if I only wanted to blink 10 times, I could do this, for example. Instead of an infinite loop, I could just say, okay, loop 10 times, and then it's going to finish. It'll be done. It's not going to run anything else because it's going to get to the end here and stop. So let's try that. Let's do the ampie run command, and we should see this thing should hopefully blink 10 times and then stop. So we'll just kind of let it go here. But that's cool. And that's the power that I'm trying to show with MicroPython, that you've got access to run whatever code you want. So you can see it just stopped looping right there. And even if you're coming from an Arduino world, there's a way that you can structure your code like this. You have your setup code at the top and your loop code inside of there so that it behaves somewhat like an Arduino sketch. Okay, let's go back to the infinite loop. So we'll say while true. Okay, so that's pretty cool. And then let's see, the next thing we can talk about are some of the file operations that ampie exposes. So I already showed you the run command. Real briefly, I won't get into all of these file options, but ampie has a whole set of commands to manipulate the files on this board. So if you run -- help, you'll see there's a get command which can retrieve a file from your MicroPython board and copy it down to your computer. The ls command will list the contents of a directory on the MicroPython board. Makedir will create a directory. Put will put a file from your computer onto the MicroPython board. rm will remove a file or a directory if it's empty. And then the run command you already saw will just run a script on your machine. So let's run the ls command. And again, remember, I'm not specifying the port option because I've set that environment variable, but you might need to specify the port. And if I run ls, it's very similar to the ls tool in your standard terminal system, or if you're in Windows, the dir command is the equivalent. In the Unix world, ls just means list the contents. So like I just listed the contents of this MicroPython files folder, which has the test.py file that we just saw right here. So when I run the ampie ls command, it's doing the same thing, and it's listing the contents of the root file system on the MicroPython board. And so you see I have a boot.py, a main.py, and a foo thing. And this is actually a directory. And you can actually specify another argument to ls. You can specify a path, like a subdirectory. So this foo subdirectory, I can list the contents of that. And you can see there's actually nothing inside of here. But this is kind of handy, you know, just think of ls like you're using the ls or dir command on your computer's file system. This is just a ls command you can run on the MicroPython system to see what files are there. There's some other commands though, like the get command. So let's get the boot.py. So get takes in a file on the MicroPython board to retrieve. And if you don't specify anything else, oops, I always misspell this when I run the ampie command. If you don't specify anything else, it will just grab the file and print it to the screen. So you can actually see this is the contents of the boot.py file on my MicroPython board right now. And so you can see it actually has commented out that debug info stuff inside of here. So you can see kind of some of the inner workings of MicroPython here. But that's one thing you can do with get. The other thing, if you wanted to save this to a file on your computer, you can just specify that. So if I wanted to save it as a boot.py in the same directory, I should just specify it as another argument here. You have to specify it as an argument though, because if you don't do that, then it's just going to print it out. So, you know, even if you want to save it as the same file name, you have to specify it again. But if I do this, now if I look and see, I've got a boot.py in this directory. You can even see it right here in my text editor. So this is handy. This is a good way to pull a file down from your MicroPython board. You can similarly push a file from your computer to the MicroPython board using, surprise, surprise, the put command. And it works pretty much the way that I would hope that you expect it to work. Basically, you specify a local file on your machine. So let's say the test.py file that I have right here. So we're going to send this file to my MicroPython board. So if I run this command, then let's run the ls command again. So when I run this, hey, notice that we added a test.py file to our board. And if I run the get command, I can get that test.py file. Oh man, I'm gonna make this mistake like 10 times on the stream. And so, hey, look, whoops, I scroll past it. Surprise, surprise, there's all the code, you know, exactly the same as what we had in the file here. So that's pretty cool. You know, with get, put, and ls, you can manipulate the file system on the MicroPython board. So you can copy over your own Python source code like this test.py file. Or if my Python code read or wrote to files on the MicroPython board, you know, I can copy those files between my computer and the Python board just using these ampie commands. So really powerful stuff. And we're not going to get too deep into the file operations in MicroPython just yet. I think in a future video, we'll look more at that. But, you know, just remember, you can use those get and put commands. And there are a few other commands. You can create directories with the make directory command. I'm not going to get into this. You know, I talk about it in the guide here. And then you can also remove files. So if I wanted, you know, let's remove that foo directory. So if I run ampie rm foo, then this is going to delete it. It won't delete a directory if there's a file inside of it or another subdirectory. So you have to go through and delete everything inside of there. There's no recursive option. Sorry. Maybe in a future version, I'll add a recursive option to go through and delete everything. So, okay, so that's the basics of file operations. So, you know, again, remember, MicroPython is pretty cool because it has a file system built into it. You know, some boards like this ESP8266 use a part of their flash memory as the file system. Other boards like the Pi board, you know, this one that we've looked at a few times, it actually has an SD card, a micro SD card that you can plug in right here and connect and actually access the files on that micro SD card. And so that's kind of cool that you can just pull that card out and plug it into your computer to copy files around. And you can store a lot of files too, you know, put a very large card in there and you'll have a lot of space for data. But you know, you could, and hopefully in a future project, we might look at how you could add an SD card to one of these little Feather Huzzah boards, because we have a little Ada logger Feather wing that has a micro SD card reader in it. So you can connect that up and actually have MicroPython use that SD card as a file system potentially too. So lots of cool things, you know, but remember, MicroPython has that file system. You can create directories, you can create files, you can manipulate everything, you can, you know, add all of your code and your assets and your media, whatever you're dealing with, configuration files, put them on your board just like you're using files on your computer. Okay, so then one last thing, let's look at how do we fix this missing piece then of, you know, when I showed at the start with my Arduino, when I ran that blink sketch, it ran every time I powered on the board. Whereas right now I have to use this ampie command. You know, right now I need to tell it to run that test.py. So if I go back and we say, okay, run that test.py, you know, now it's running it. So that kind of sucks because, you know, watch, if I unplug and plug the board back in, it's not running anymore. You know, I've got to run that command and now it starts. But there's a way that you can fix this. So in this boot scripts page of the guide, I talk about there are two special files that MicroPython looks for on the root of the file system. There's the boot.py that you've already seen that I was actually showing earlier. And so that script is run, and it's meant to do kind of low-level startup code that's specific to the MicroPython code that's running on that board. It's not for your user code. It's more for the MicroPython, I don't want to say operating system, but for the firmware to do any initialization and setup. So like you can see, the boot.py for my ESP8266, it's just looks like it's doing a garbage collection, and it's not even like turning on the web REPL, and it's not disabling debug output. If I wanted, I could have it do that though. So like, let's uncomment this OS debug. You know, remember, this is what I mentioned, to disable debug output permanently. So let's just save this, and let's put this file back on our board, because remember, boot.py is just another file on the file system. You can use all the ampie commands that I've shown previously to manipulate this file. You know, you can read it, you can put this file from your machine. So let's just put the boot.py onto my board. So I'm going to run the put command, and you might have noticed it stopped blinking, the LED. That's just a side effect. Whenever you use an ampie command, it interrupts whatever script was running on your board. So you just have to restart the board or the script yourself. So, you know, I'm going to run the run command again to kick it off. But now if I get the boot.py again, we should see that it's modified. So I'm just going to use the get command. And yeah, notice, oops, that it's uncommented. So it's going to disable the debug output every time the board boots up. So that's what the boot.py does. Again, it's not really where you want to put your startup code, because luckily they thought about that with MicroPython. There's another file, the main.py, and this file doesn't have to exist, but if it does exist, it's run after the boot.py, and that's where you want to put your code that you want to start running whenever the board boots up. And so I talked about in the guide here that you could take, like, you know, your infinite loop code that's maybe blinking an LED or printing things out. You could test it out using the run command with ampie, you know, like we just saw right here. I was using the run command here to run this code. And then when I'm happy with it, I can go and say, okay, let's save this test.py as the main.py file. So now whenever the board starts up, it's going to start blinking the LED. It's going to start running that code that was in the test.py file. So let's try it, and I'll show you. So remember, I've got that test.py file on my local machine right here, and it's just going to run this infinite loop that just blinks the LED over and over and prints out some console output. So let's do the put command, and then let's put the test.py file. But instead of putting it as test.py on the MicroPython board, let's put it as main.py. So you can specify a second argument to the put command. And this is basically, the first argument is the file on your local computer that you want to copy to the board. And then the second argument is what file to save this under on the board. And you could put this under a different path, you know, if you have like a foo subdirectory or something. But we're not doing that here. We want to save this as the main.py file under the root of the board. So that means, you know, no parent directory. You could actually specify a slash in front of it if you wanted to be explicit about it. But let's do that. We'll put this under that main.py file, and let's just run the ls command. Let's see all the files. So now notice I have a main.py on my board, and if I get that file, if I do ampie get main.py, we should see, you know, no surprise here, it's exactly the code that I expected. Let's see what happens. I'm going to press the reset button on the board right here, and we'll see what happens here. Hey, check this out. It's blinking. So that's pretty cool. Like, my code must be running, and it started automatically. I didn't run any ampie command. You know, you saw right here, I just reset the board. Now let's look at the REPL. So I'm going to connect to it with the serial tool. And you can see it's printing out, blinking every second. So I know for sure that my code is running on this board right here. And that's pretty cool. So I'll exit out of here. You know, all I did was save that file as a main.py file on my MicroPython board. I pressed the reset button, and it just sprang into action. It started running that main.py file. You know, basically what happened, the board booted up, it ran boot.py, so it disabled debug output and did whatever stuff was inside of there. And then it noticed I had a main.py and it started to run that script. And so that's kind of cool. And that's what I really wanted to get at the end of this guide here, and really just kind of mentioning, this is how you can create an Arduino-like workflow with MicroPython boards. So Arduino-like in the sense that you run code, or you type in code on your computer. You know, with Arduino, you use the Arduino IDE or editor, whereas with MicroPython, use whatever text editor you want. If you want to get fancy, you know, you can use something cool like the Atom text editor. If you want to keep it simple, use whatever works. It doesn't matter. Just make a text file. And then using the ampie tool, you can test that code. So, you know, use that run command to send your script to the MicroPython board. And remember, use the no output option if you're using like an infinite loop, because you've structured your code in a similar way as an Arduino sketch. So you've got your setup code at the top right here, stuff that runs once during the startup of your board or startup of your code. And then you have a loop here that just runs forever. And inside of that loop, you put your loop code that just is run every single time the board goes through this kind of loop process. So, you know, you can put in your logic here to blink an LED, or maybe like read a switch, or talk to a web service, or do whatever. You know, we're going to look a lot more in future videos at fun stuff you can do. But this is really the basics of how to make something with MicroPython that feels a bit like an Arduino. You know, you can write the code, you can have setup code and loop code that runs the way that you would expect. So you can use that run command, you can test out your code on the board with that, and then when you're happy with it, you as a main.py file on the board, and you're done. Suddenly, you know, you reset your board, or here, I'll unplug it, and I plug the board back in, and my code's going to run again right there. It's going to blink the LED and keep running, just like you saw with Arduino. You know, the MicroPython board remembered that file because it has this file system in flash memory, and that file just has the Python code that should run. So very, very powerful kind of thing that, you know, you've got access to this file system. And using a simple little tool like ampie, you can run files, you can load files, you can read files, you can just do all the basic file manipulation that you need on the board like that. Okay, so I think I'm going to wrap it up then. If folks have any questions, maybe throw them into the chat right now, and we'll see if we can get to them. And let's see, I'll stay in this view because the main view can be kind of annoying sometimes with questions. So let's see. Can MicroPython be used like Nightlight? I've not used Nightlight, so I'm not sure what that is. I'll have to look into it and see. Could MicroPython work with Visual Studio Code? Good question. You could totally use the VS Code editor. So I mentioned Atom is a text editor. VS Code is another text editor. This stands for Visual Studio Code, and it's not Visual Studio. Visual Studio is a whole separate commercial product. Very nice code editor for Windows code. Visual Studio Code is a text editor in the same style as Atom. And so you can write Python code, you can write JavaScript, you can write all kinds of code in Visual Studio Code. And you could use this with MicroPython also. So just like I showed with the ampie tool, write your code in Visual Studio Code, save it on your computer locally, and then use that run command to send that file to your computer or to your MicroPython board, and it should work great. So yeah, you could definitely use the Visual Studio Code editor for it. But the one thing to realize, as far as I know, none of these editors know about MicroPython as a language. Now, MicroPython is so similar to the Python language that all of the syntax highlighting and stuff that you get from your editor will probably work and make sense. But just realize, you know, all the standard Python libraries aren't going to necessarily apply to MicroPython. And go back to like the first or second video, I talk a little bit about some of the differences in the libraries there. Yeah, someone's wondering, could you write an extension for VS Code that maybe automates using ampie? Totally could do that. That would be really cool to do that. If someone wants to try it, you could write an Atom extension if you wanted to for that. So that's cool. And otherwise, so cool. Someone mentioned they're building a robot. Very cool. Yeah, I think MicroPython is a cool platform for building little robots. And I actually, hopefully in a future stream, that's one of the projects I want to look at is, you know, putting together some of the different parts we have. Like there's a motor wing that you can plug into this little ESP8266 feather, and that could drive a couple motors and maybe have some sensors and things connected to it. So, and then have Python code controlling your robot. And since it's the ESP8266 with a little Wi-Fi microcontroller, you could have have a web page that it shows that maybe has buttons that let you control the robot. So lots of cool stuff that hopefully we'll get to in the future. But for now we're just focusing on some of the basics. How do you get this Arduino-like workflow of writing code on your computer, pushing it out to the board over here, and then having that board run your code forever, just like you see right here, like blinking this LED. Okay, so that's it. I'm going to end the stream then, and I'll jump back to the main view real fast, or the headshot view here. So that's it. I'm Tony from Adafruit. This was how to load files and run code on a MicroPython board. I like to stream a couple times a week, so if you check out twitch.tv/Adafruit, you can watch me stream these things live. I like to do a stream on Mondays and on Fridays, and all this month I'm doing MicroPython related streams. So I've done four of them so far on some of the basics, and I'll put a link down to the guides that I've written in the description below when this goes up on YouTube, so you can see the previous videos and guides there. But then check that out. Also check out youtube.com/Adafruit. You can see this video, all kinds of other fun projects and videos up there. Lots of new content. Almost every day we've got new stuff coming out. So check it out. Lots of great stuff there. And if you like this, hit the like or the comment or the subscribe button. Let us know that this is cool stuff and it's useful info. And we'll keep making fun content like this. So until then, this is Tony from Adafruit. Thanks for watching.